if I don't say hit record. All right, welcome Linda, and welcome Claudia, and welcome Michelle, welcome Kelsey, and Stephanie, and Morgan, and Lizbeth. We got a nice group today. Hope we could get more. It'd be great. So let me tell you the plan. The first thing is this is the week of the central limit theorem. The central limit theorem is the most important theorem of the entire quarter. So it is what pretty much, if it didn't exist, we wouldn't even have this class, because this class wouldn't work. And not just like at Lake Tahoe, but anywhere in the world. But the central limit theorem is why we can do statistics. And we'll see that. So the last chapter we did was chapter 6. And if you remember, that was all about the normal distribution. And what I did a terrible job in, on purpose, was convincing you that you care. Like, here's some silly distribution, and we're going to spend a whole chapter dealing with it. And it kind of seems useless, right? So today, you're going to see why we care. Why pretty much everything you ever do when it comes to data analysis uses the normal distribution. And that's a big deal. And it's just weird, actually. It's not something, I didn't make this happen. It's just one of those things about nature, and it's proven, it's true. The whole world is a normal distribution. The whole universe is the normal distribution. But we'll talk about why it is. And so again, I'm going to go through a bunch of stuff. I want to talk about where I am right now. Today was a really busy day. I taught all my classes. I had 2 meetings. But fortunately, I was able to wake up at 4:30 in the morning and get what I had to do done, and then grade your discussion forums. So today, I just wanted to get that over with so I can start the bigger job, and that is grade your projects. So I've not looked at the projects yet. That's tomorrow. I'll be looking at the projects, and then Wednesday and Thursday, they take a long time because they're a lot of pages each, and it's not just checking, did you get it right? It's reading it and analyzing it, and then writing comments. So a couple things is when I do grade the project, only one person in your group, the person who submitted it, is going to see the grade. Okay, not the letter grade. You're all going to see the letter grade, but see my comments. So you're responsible for sharing my comments with your group. Can you promise you'll do that? Okay, or promise that you'll ask your partners to share with you if you're not the one that submitted originally. But the point is that there will be lots of comments. I put comments right on the paper that got submitted, and I also put comments in the little comment box as a summary of the comments in the paper. So that's just a note, but I will be doing that. It's this week's project. It takes many hours for me, so over the next few days I'll be doing it. So usually alphabetical, whatever submitted, just because that's how Canvas works. It just sends that one first. So sorry if your last name starts with a Z, but it happens. So that's my issue, my timeline. The other thing is this week has something special in it, and that is there's the online exam. So there's been a couple questions already. It is not a proctored exam. Okay, you shouldn't cheat. Please don't cheat. But there isn't going to be a policeman standing watching you, or a proctor. Because if you do cheat, you're going to probably not learn the stuff, and you probably won't do well on the regular midterm. The proctored exam, kind of like the assignments that you do when you work out problems, except that you only get one chance for each problem. You get it or you don't get it, because it's more like, try to make it more like an exam, and that's how exams are. And it's much longer. It's much longer, so be ready. Be ready to spend some time on it. Okay, it's going to take time. There's unlimited time. Well, there's a limit. The limit is it has to be done by Sunday. But otherwise,
can you log out and then go back into it, or do you have to?
I think you can log out and go back in. I'm pretty sure you can. I think once you submit a problem, it's submitted though, forever. And I'm pretty sure you could log out and come back in if you've been working on it for an hour and you got to do something or you're tired, then you can do that. If you're worried, you can always keep that tab open. Okay, but it's a good question, but I think so. It's hard for me to know because I can't really test it very well, because I'm not a student, because I could do whatever I want with it. I could change the problems, I can get the answers, I can get everything. But you guys can't do that, of course. But I think you can log out and come back in. That should be doable. If you try and you can't, please let everyone know you can't. And then I'll do my best and I'll make sure that you get another shot at it. But only one person gets to do that, so you better tell me right away if it doesn't work. But it should work. Okay, so that is a big deal. Otherwise, the assignments are pretty light. Those who post on the discussion forum, it's a very basic, easy one. Do you agree? Anyone post yet? I know I have a couple posts. Yeah. Do you agree that was like the easiest discussion forum of the quarter? Yeah. But, you know, it's a trade-off. You get the easy discussion forum, and now you got the online exam. So just a note is that it's, it's a trade-off. Okay, so are there any questions at all about any of that?
I had a question.
Sure.
So for the online exam, will it be on chapters 1 through 6, like it said on the syllabus, or?
Exactly, it's chapters 1 through 6.
Okay.
And what I did is I took the problems from chapters 1 through 6 assignments, and it's going to randomly pick a bunch of them, and you're going to get those. Everyone's going to get a different online exam.
Okay.
It's a random picking. So if your favorite problem is not on it, I apologize, but you just got unlucky. So that's how it works. So I grouped them in much bigger groups, and you get one for that group, is the way it works. Does that make sense?
Yeah.
Yeah, so it's going to look a lot like your regular weekly assignments, except it's longer and you only get one shot per problem.
So to do better, should we practice on the other ones?
That's a good idea. Yeah, so that's a good idea to do better. Very good idea. It's the best way to practice, get ready for this particular online exam, is to practice chapters 1 through 6. Because, again, you'll see the same problems. I mean, the problems are random, so you'll get different ones necessarily. And the numbers are random, so you'll almost never get the same number. The probability is basically 0 that all the numbers are the same as what you've gotten. Okay, it's close enough to 0. Any other questions? Okay. All right, I thought I would introduce the central limit theorem with the big, for some of you, ugly thing in the news that happened today and Friday. And what was that?
Stock market crash.
The stock market crash. So I thought I'd talk about it and talk about some strategies, and depending on what you want with your investments, because again, it's in the video, but it's also going to be in this in a little bit different way. And let me pop it in just a minute. There. One more click. Okay, so hopefully you can all see it. So this was the big news of the day. The market dropped. I wouldn't call it a crash. It's 4.6%. Right? Don't look at the number 1175. It's 4.6%. That's not usually called a crash. It's usually called an adjustment or a correction. A crash is more like 20 or 30%. That's a crash. 1987 we had one. That's the last crash. And then we had a long-term crash in 2008. So the question is, how do you prevent losing everything you got in your stock? And it's a good life skill to have. I know maybe some of you have some investments, some of you don't. But hopefully, eventually in your life, you'll have some investments, because it's a good thing. So what you want to look at is risk. So what's the statistics word for risk? You all know it. Here's it. You had to write a paragraph on it in your project.
Is it the standard deviation?
Standard deviation. So the statistics word for risk is standard deviation, because you have your mean, which is like 9%, which is the mean increase in the market. But you're not going to get your mean every day, right? Or with every stock, because there's a standard deviation. Some days are going to be like this disastrous day today. And then some days are going to be higher days, and some days are going to be a 9% annual return day. Does that make sense? And the standard deviation will tell you how much it's going to go up and down, and the risk is if it goes down, right? Okay. If you put money in the bank, whatever bank it might be, then what is the standard deviation for your returns?
The interest rate.
No, that's the mean. The interest rate's your mean. That's your mean return, right? The hint is it's really easy.
The monthly increase.
It's zero. It's zero because your money goes up, and you know exactly what it's going to go up. It's going to go up that 0.5% because that's what you get in your bank. And then the next month, it's still going to go up to 0.5%. Does that make sense? And there's no risk. So if you're willing to have a little risk, then you can get your mean higher. So in terms of investment strategy, typically, not completely, but the higher the risk, the higher the standard deviation, the higher the mean you'll be able to get. Does that make sense? So if you're willing to have a little bit of risk, doesn't have to be giant risk, but a little bit of risk, you should not put your money in the bank. Because that has standard deviation of 0. You have a horrible mean, right? Like 0.5% mean, which is like nothing. But you know that you're not losing your money. Does that make sense? That's what FDIC insured is. It ensures that standard deviation is 0. Is that clear? Okay, on the other hand, if you put in the stock market, you'll have days like today. But the best thing you can do is you find risky investments and many risky investments. And risky investments where if one goes down, the other's not necessarily likely to go down. So in statistics, in chapter 3, we call those independent. Does that make sense? In stock market language or investment language, anyone know what they call that? Starts with a D?
Dow?
Good try, but actually Dow is not. Diversified.
Oh.
So diversified means that they're independent. If one goes down, the other's not always going to go down. Do you see that? Whereas if you invest all in the same thing in 4 different stocks that are all exactly the same, then you don't have that independence. But if you have the independence, then what you can do is you can have the mean being the average mean of the different stocks you're investing, or the different investments, not necessarily stock. And then the central limit theorem, and that's the big theorem of the whole class, is that the standard deviation is going to be decreased by a factor of the square root of the number of investments you have. So if you can find 100 diversified investments, and each one is risky, but has, say a 10% average return, then you take that risk and divide it by, or let's say it has a 12% average return, just so you don't get confused on numbers. You take the risk and divide it by the square root of 100, because you've diversified into 100 different investments. And that means you've dropped your risk by a factor of 10. That is gigantic. Okay? Any questions on that? And then you're basically almost guaranteed with a super low probability that you are going to get what that average is, which is 12%, instead of putting it in the bank, which you're guaranteed an average of 0.5%. Do you see how that works?
So you're saying that based on your investment, you should do the square root of 100?
If you have 100, if you can find 100 diversified stock investments, places to put your money,
right,
then it's square root of 100. If you find say 49, it would be the square root of 49.
Okay.
If,
And
however, if you have 2, it's the square root of 2.
So based on that, it will drop to, the probability would be a 12% profit?
Right, so that 12% won't fluctuate as much because the standard deviation is how much it fluctuates from the mean. And you don't want to fluctuate from the mean very much. So, and those investments, by the way, in reality are not all stocks. Okay, they're real estate, they're international funds, because if you can invest in India, for example, that's very different than America. So if America goes up, India might go down. America goes down, India might go up. And then you have leveled off your risk. Do you see how it works? So that is what's called a diversified investment portfolio. So it's really, really important for your own finances. Does that make sense? Okay, as soon as you have enough money that you can do a little bit of a risk, there's still a little risk, but less risk if you can diversify. There are funds at which they diversify for you.
Like your 401k.
Well, it depends. I don't have a 401k. I have a 403b. So maybe your 401k. So if you have a 401k and you have a diversified investment fund in your 401k, then your risk is low. You see that? But your returns are high.
Right.
The returns are the mean. Your average return is the mean. Your risk is the standard deviation. Do you see how that works? But it's going to be the standard deviation divided by the square root of the sample size. And that's the idea of the standard deviation. I mean, of the central limit theorem. Any questions on that so far? So the central limit theorem is really important. But let me tell you why it's important for statistics instead of finance, because that's important too. You all did your projects, right? And you all asked a group of people, and you asked them a question and got some numbers and got an average, right? And your average is, hopefully you know, is called a sample mean. Do you all agree?
Yes.
All right. There's the population mean. Do you know the population mean for the question you asked?
Yes.
The answer is no. How do you know your population mean?
Based on your spreadsheet?
No, that's the sample mean. The population mean is everyone in the world you could ask, or everyone in the population, everyone at the college, or that you couldn't ask everybody, right? So you can't know the population mean. Does that make sense? It's not possible to know the population mean for a large population. You know the sample mean. That's easy. That's your spreadsheet. Is that clear? So the big question of the entire quarter is your guess a good guess? So you have the sample mean, and is that sample mean likely to be close to the population mean? Does that make sense? If it's not likely to be close to the population mean, you have a completely useless sample. Is that clear? We found out that if you have a lot of bias, then you're not likely to be close to the population mean. For sure. It's just off. Okay, but if you have no bias, you still may be away from the population mean. So here's what's wonderful about it. The standard deviation tells you how likely you are going to be close to the population mean, right? Because that's the variation from the population mean, right? How far up and down you go from that true mean. Does that make sense? But if you have a sample and your sample size is large, you get to divide that standard deviation by the square root of the sample size. Same reason why you get to do that for investments. Any questions on that idea? So if you have a sample of size, say 36, that's kind of in the ballpark what most of you guys have, because I said more than 30, then your standard deviation goes down by a factor of 6, because the square root of 36 is 6. Is that clear? So because of that, you can be a lot more confident that your sample mean is close to the population mean, right? Because you can be confident by a factor of 6, which is gigantic. But there's even better. So if you have a sample, most of you looked at your sample, you looked at the histogram, you looked at the shape of the histogram, and was it normal? Most of you know, right? It wasn't really normal. Some of you, a couple of them look kind of normal. Most of you, it wasn't a normal distribution at all. And here's the problem. We don't know how to calculate probabilities if you don't have a normal distribution, do we? Is that clear? Because there's no calculator button that says, I don't know CDF. That'd be great, wouldn't it? There isn't one. There's only a normal CDF. Is that clear? So the good news is that if you have a large sample with a sample size greater than, any guess on what number it has to be greater than? Think about your projects, that's a hint.
30.
Greater than 30. And that's why in your projects, I said you had to have a sample size greater than 30, because if you have greater than 30, then you're guaranteed that the distribution, what's called the sampling distribution, is all possible groups of 30 will be approximately normally distributed. And that's usually within a decimal place. So having a large sample size allows you to use the normal CDF on your calculator. So that is the central limit theorem. Okay? It says that the standard deviation gets dropped by a factor of the square root of the sample size. The mean of all different possible groups is going to be the same as the mean of the population. So that means you don't have bias. Because bias would mean that you'd be lower or higher, and you don't want to do that. And you have a normal distribution for all possible groups. Any questions so far? Okay, so that's a big deal. And again, I'm not going over every little detail. That's what these long videos in the book's for. I go over highlights and then examples. Okay, let me unshare this part of my desktop. That's this one. And let me pop in an example question. Okay, so here's an example. Okay, so suppose that the number of hours per month the college students volunteer. Okay, any of you volunteer at all? Do you ever volunteer for anything? Good, good. But let's suppose that the number of volunteer hours per month has a mean of 2.8 and the standard deviation of 6.7. For all of the following questions, do all of the following. Write down the indicated distribution, sketch the appropriate diagram, answer the question, and state whether the normality assumption is needed. So I want to ask you something. How many things do you have to do for each of these? How many did I read? Not a trick question. You're supposed to count.
4.
Yeah, 4. Okay, so for each of these, there are 4 things to do. I will guarantee that your exam, your written midterm, will have this, the last part of this question on it. It won't be volunteer and this mean and standard deviation. It'll be a different mean and standard deviation. But you're going to have this question. How many things are you going to remember to do when you do it on the test?
4.
I hope 4. I hope 4. I have found usually about half the class doesn't remember to do 4. It's not a trick question. The 4 things are there. I got it written down. And then I'll see 2 of them. And I go, ah. So put a big star. 4 things to do. And then ask questions as I'm doing so you know how to do them. Sound fair? All right. So the first question. If a college student is selected at random, what's the probability that that student volunteers at least 5 hours a week? So I want to let you know this is actually a Chapter 6 question. Okay, this is a Chapter 6 question, but it kind of goes with Chapter 5. And I'm showing you this because your midterm exam is going to have different parts from 5 and 6, from 6 and 7. So the first thing I need to do is I need to write down the distribution because there's 4 things. So the first thing is it's a single college student. We're not talking about a mean or anything like that. We're talking about an individual. When you have an individual, the variable we use is x. You've seen that before, right? And then tilde. Remember the tilde? And now we write down the distribution. The distribution is normal, right? So what letter?
N.
N. What's the mean?
2.8.
2.8, comma, the standard deviation was 6.7. Not a trick question, that's number one. I would say about a third to the half of the people that take my test don't put that down. And it's the easiest part, isn't it? So please don't be in that group. And hopefully, this is a different class. I'm hoping I have 100% put that down. No trick questions. But when I say sketch the distribution, write down the indicated distribution, that's it. Is that clear? So you need to write that down. You know how to write that down. It's not a tricky or anything. You just do a couple practices and you'll be able to do it. Then the next thing is sketch the appropriate diagram. Okay, what's the shape of the diagram? What do you think? Come on, you should all know it's the shape we always use. We used all last week.
Bell shape.
Bell shape.
Normal.
So it's going to look like a normal distribution. I don't expect you to be great artists. I'm terrible when it comes to using a mouse trying to draw a normal curve, but that one's actually one of the better ones I've done. But you should have something that looks somewhat bell-shaped. Don't draw a rectangle. Got it? When do you draw a rectangle? What word are you looking for rectangles?
Probability?
No, not probability, because this is a probability also. See, part A has the word probability, right? Starts with a U. That's a hint.
Uniform distribution.
Exactly. Uniform distribution. That's rectangle. But here it has the word normal. When it has normal, it's bell-shaped. Got it? Right in the middle, the mean is 2.8. Any questions on that? We want the probability they're volunteering at least 5 hours. So 5 is going to be bigger than 2.8. You better all know that. And then I'm going to shade in at least means it could be bigger, right? So I'm going to shade in there. Okay, so that's part 2. Part 2 is write down the sketch the appropriate diagram. Any questions on that? Okay, part 3 is answer the question. Okay, and to answer that question, we're going to need to use our calculator. And this is a normal distribution piece. So let's answer the question. I got to unshare my desktop and then reshare it with my calculator. So now I'm going to go to second distribution, normal CDF, because we have a normal distribution. From the picture, the low was 5. The high is a bunch of 9s.
Oh, did I go the wrong way?
The mean was 2.8. And again, you may have the older kind of calculator, but you should still need to use a calculator and know how to do it. Standard deviation is 6.7. By the way, every quarter, and it just like, why? I get a student that comes to the midterm and doesn't bring their calculator. It's over. Please don't be one of them. You have to have a calculator for the midterm. You can't pass it because you just can't answer this question, right? No way you can be able to do it without the calculator. But with the calculator, it's not too bad. I hit enter and enter again, and there you go, about 0.37. Any questions so far? Okay, so now let me go back to the question. And we had 0.27. I forgot to write in my picture, and I should. That was 5 right here. So we said the probability that x is greater than 5 was equal to 0.37. On the computer, by the way, you need to use probably 4 decimal places. So I got a little shorter on the webinar problems, but hopefully you can do 4 decimal places. Any
So
questions so far?
before you answer, you have to do that on the exam as well, or just write the answer?
Do what?
The P parentheses.
You don't have to, but I do it for teaching purposes.
Okay.
Otherwise, people get confused. So I think it's definitely helpful for learning, don't you think? Okay, then, have I done all 4 things?
No.
No, there's one more. It said that we need to, it said assume that we had a normal distribution here. Was that needed? Could I have erased that word normal distribution, and could we have still done this? And the answer is no. Okay, had it been a uniform distribution, this doesn't work. Is that clear? Then you would have done a rectangle and figured that out. Does that make sense? But it's a normal distribution, so we need, so the normality assumption was needed. Any questions on that? And now we've done the 4 things. What I recommend is going like this. Because that'll help you not forget. So if you list 1, 2, 3, and 4, you'll remember to do all 4. If you don't, I know what happens. And I'm just telling you from my experience, I've been teaching this for a long time. And I haven't figured out how to get everyone to do 4, other than say it 100 times. That doesn't always work. Any questions so far? Okay. I just want to note, you don't need to do any kind of z-score. We didn't need to do any algebra or weird calculation. We just used our calculator. I've noticed that some of you on the discussion forum, a couple of you did it the long way, and there's no reason to, unless you like torturing yourself. Is that clear? All right, so next is part B. So let's look at part B. If 55 students are selected at random, what is the probability their average is between 3 and 4 volunteer hours per month? Okay, that is very different. What's the key word here? Which makes this at B very different than A.
The amount of students?
No, I like what Morgan said, average. Average. So we're looking at the probability the average is between 3 and 4, not one person that you selected. And because we're talking about the probability of an average, now we're using central limit theorem. And the central limit theorem says the following. It's what I said, but again, what I say and what you remember is not always the same thing. It's no longer x, it's x bar, which I'll write, maybe I'll write with bar. Now I think I'll write it and I'll put it in later, it'll be easier. Tilde, and it's gonna be n, we're still gonna have the same mean, 2.8. And the standard deviation is no longer gonna be 6.7. Do you remember how you do it if you have a whole group? 6.7, what I kind of mentioned at the very beginning. And you divide by what? Remember? The square root of the sample size, or the square root of 55. And I got to fix it because that's not quite right. I just can't type what I need to type. That's an X bar. Because it's an average, it's a sample mean is normally distributed, not an individual. Because like that investment idea, it's not what one individual stock does, it's what the average of all of your stocks do. That's all that matters. Because you care about your portfolio, not anything individual. Does that make sense? And, oh, I need one more parenthesis. I lost. Look at that. That's not very important. There. Any questions on the distribution? A lot of people, yeah.
Do you divide by the square root of 55?
Yep, that's what it says. 6.7 divided by root 55. I did it with words instead of symbols. It's hard to type symbols. So I use root. We all understand that means the square root of. Any questions on that? Okay, then we go ahead and draw our picture.
Hey, Larry.
Yeah.
In the notation, do you want exact or approximation of the 6.7 divided by the root?
I recommend not approximating. And the reason is when you put in your calculator, you should never approximate until you're done. Otherwise, you may have round-off errors, and you could get it wrong on the assignment. Does that make sense?
Yes, thank you.
If you wait till the end, you'll be much better off.
Quick question. On your calculator, do you put 2 parentheses after the square root?
Yeah, well, if you just count the parentheses, you'll notice it was a parenthesis after the n.
Mm-hmm.
So the last parenthesis closes that one.
Mm-hmm.
And then there's a parenthesis after the t, and that parenthesis closes the root. That's
Okay,
not very important, though. I wouldn't take off a point if you forgot that parenthesis. But that's just, parentheses should open and close, right? Yeah, so that's not very important in terms of worrying about concepts or anything. What is important is you understand that it has a bar over the x, because we're not talking about x, we're talking about the mean, the average, and you're dividing by the square root of 55. You're not just leaving it at 6.7 like we did on part A. You see that? That's what you want to get. That's the take of this. Then we can draw our beautiful picture. Not a bad one. Sometimes they're bad. This one's not so bad. And our mean is still going to be 6.7. Sorry, 2.8. We want the probability, the average between 3 and 4. So now I'm going to go to 3, which is somewhere like this. I don't know exactly where it is. I don't care if you know exactly, but you should know that 3 is bigger than 2.8. Everyone good with that? And 4 is bigger than 3. I'm going to shade that in. Then I'm going to put in the numbers, 3 and 4, and I have my beautiful picture. Any questions on that? So force yourself to draw this picture. If you don't, you won't get it right on the written midterm. So when you're doing the assignments, because it's computer, it's not going to know if you've drawn the picture. But I'll know when you get to the midterm because you're going to have to draw the picture. That's written. And if you haven't practiced, you won't get it right. Okay, then the third is answer the question. So now we need to go and answer this question. So I'm going to go to my calculator. I'm going to go second distribution, normal CDF. My lower here is 3. The higher is 4. The mean was still 2.8. The standard deviation is not 6.7 anymore. It's 6.7 divided by the square root of 55. Any questions so far? And then hit enter, and enter again. And it's about 0.32, right? On the assignment on the computer, you go 0.3204 or something, right? So we can say the probability, I'll just type in 0.32 for the third piece. If you want, if you're not sure if you can get it right, Here's my recommendation in terms of the work to show. Do this. Oops. And then I can look at it and give you partial credit if you made a little mistake. Does that make sense?
Mm-hmm.
So that's a little trick in getting points on tests. So on the midterm, make sure you show that, then I can give you some points. Otherwise, if you just have a number that's not right, I can't give you anything.
I can't see the screen.
No, I can't see it.
Oh, I'm sorry. I just realized I forgot to share. Thanks for reminding me. Forgot to switch it out. Okay. Now you can see it. So do you see what I did?
Oh,
So
okay.
normal CDF. In other words, write down on a piece of paper what you did in your calculator.
Okay.
So I got a totally different answer than what you did.
You did? You put
Yeah.
the same numbers in?
Mm-hmm.
3,
And
comma
you
4,
did.
let me read my numbers again. 2.8, comma 6.7 over root.
I did 6.7 over root, and then it created two parentheses, 55, and then they closed the parenthesis, and I got 0.0080.
Are you sure you had everything else exactly the same?
Mm-hmm.
Normal CDF 3, comma 4, comma 2.8, comma 6.7 over root 55.
You have to put a parentheses around your 6.7 divided by square root of 55.
You do have to put parentheses.
Yeah.
Okay, see, that's what I was asking earlier. Okay, thank you.
Yeah, we'll try it and see if it works. But you should get 0.32. Okay, but the good questions. Again, that's the point of the webinar. That way we can make sure that we all get it. Whereas the video are good, but you can't ask questions as you're watching the long videos. Okay, any questions on this one? All right, so now
What
part
would the
C.
answer have looked like? See, number 3 for the first one is P parenthesis X greater than. So what would the answer have looked like down on this
Okay,
one?
let me do it with a pencil. I didn't do it because it's writing, because it needs symbols. So let me put those in.
You just say it.
Yeah, no, it's easier to actually write. I'm going to just write with a pencil. But just don't mind if I have bad writing. So P.
3 greater than or less than X
But it's not X.
N.
No. So 3 less than X bar.
X bar. Oh, okay.
And that's important. It's an average we're looking at. So I'm glad you asked because I should probably put that in. It just takes a long time to rewrite it because X bar is not something I can write. You can't type X bar.
Equals 0.32. Okay. I had put the X bar in the wrong spot. That's what I was asking.
Yeah, and Morgan's got it. 0.3204. Again, I didn't put the 04 part, but it was in there. And X bar.
That's the answer for that.
Yeah, the X bar is important. What's the fourth piece? We've only done 3. What's the fourth thing we need to do?
So number 4. Since it was 55, you didn't need.
Right. So by CLT stands for central limit theorem, n equals 55, which is greater than 30. So the normality assumption was not needed. Any questions on that? Because that's what the central limit theorem tells us, is that as long as we have a sample size greater than 30, you're good. You don't need the normality assumption. And remember, what are the first 3 letters of assumption?
Mhm.
You don't want to ever have to make an assumption, by the way, because that's what you're doing. You're making an ass out of you and me, is assume. So it's assuming anything is a really bad idea. So if you have the central limit theorem, you don't need to. You just know you're right. And I do want to make a remark. It's not like 30 is a truly magic number. 30 is like within a decimal place. 31 is pretty much the same as 30, so is 29. But in this class, we just got to pick a number to use. And 30 is good. I've seen books that use 25. More books use 30. Some use 100, because then you get a couple decimal places, which is even better. Does that make sense? So the higher, the better the normality is. But 30 is pretty much good enough, over 30. So in our class, we're going to call it over 30. So 31 is the smallest number we can use.
So if you got 31, then the normality was needed?
Was not needed. 31 is bigger than 30.
Okay, so it's always a higher number.
Right. But in the real world, it's not cut and dry like that. Does that make sense? The higher, the better. But we have to have something that's convention in this class.
Okay.
Okay? If you have 100 or 200, you're always okay. But 30 is that borderline-ish. Does that make sense?
Okay.
Okay. I will often have students, and by the way, I should let you know, once I'm your professor, I'm always your professor. So if you decide to go get a master's and need help with statistics, then I will help you. If you come and email me or come visit Tahoe if you don't live here, I'll help you out with whatever statistics you're doing.
So you'll meet up with my financial advisor to guide me on my stocks?
Yeah, what I'll not do is I will not tell you what stocks to buy, but I'll give you some portfolio advice. But I don't tell you what stocks to buy because then you get really mad at me if that stock goes down.
Okay.
But I'm watching because I'm a buy in the dip person.
Okay.
Because I understand statistics. I'm not going to tell you what stock. I'm following a stock, and if it goes down tomorrow, I'm buying. So we'll see. And I make money that way. A lot. Okay, so anyway, that's a whole different matter. So the point is that be ready to come and ask me when you get in your master's. But a lot of times the conversation ends in tears. Because I will be honest. And if you have a sample size of 12, I will let you know that you have a worthless study. Got it? So hopefully you learn that in my class so the tears don't come out when you go get a master's degree. Does that make sense? That you need a large sample size. If you have a small sample size, you can't do anything with it. It's pretty much over. Is that clear? Okay, and by the way, if you're not getting a master's, if you have a business and you want my help, there's a cost. If you're making a profit, you want to know what the cost is? Any guess?
10%.
I don't ask for anything, but I require you to give money to a scholarship fund.
That's pretty cool.
Yeah, so, and I've had that. In fact, I had one that was over $5,000. I helped him a lot with his business. So anyway, that's my deal in this class. Okay.
So I can save this recording for the future?
I'll go by it. I've been doing this for 24 years or so. I won't go, I might get too old. I won't remember anything. Okay, so part C. Find the IQR. Hopefully you remember. What does IQR stand for?
Inner quartile.
Inner quartile range. For the sum of 15 randomly selected college students' volunteer hours. Okay? So the first thing is the word sum. That's kind of the key word on this one. So you got to remember the symbol from algebra that you used that meant sum. Do you remember what it was? Yeah, good. I like your fingers. You're doing great. So I'm going to have to draw it with my pen because there's no typewriter key on it, keyboard key on it.
Are we going to have to write like this on the test?
What's that?
Pen thingy bobber that you're doing?
Uh-huh.
What?
You write it. You'll learn how to write that. You don't have to type it. But you put it on a piece of paper.
Oh, on a piece of paper, not on the computer though. I don't have to do what you're doing.
No, well, on the computer, that part, you're going to have to do it, but it'll be multiple choice.
Okay.
It'll give you X bar, sigma, or X, and
Okay.
there'll be a pull-down menu, and you have to click the right one.
Okay, good. Okay, I can do that.
And you have to, the hard part is knowing which one to click. On the written exam, you have to write down. No, I don't make you put it with a pen.
Okay, good.
But you should know it's sigma X. And by the way, unfortunately, it's still the word sigma, but it's capital sigma instead of lowercase sigma. Just like the English alphabet, this is a Greek alphabet. Lowercase sigma is the standard deviation letter we use. And capital sigma is this. So sorry about that. Don't shoot the messenger. And now let's write out what we get. That is a tilde, n. The mean now changes, which you should expect. If you ask 15 people, you do not expect their sum to be 2.8, right? That would make sense, right? If an individual you expect to be 2.8, and you added 15 people's answers, you wouldn't expect 2.8, would you? You would expect 2.8 times 15, because there's 15 people. Does that make sense?
But don't you want the line over the X after the
No, because sigma X. It's not sigma X bar, it's just sigma X. It's the
Oh.
sum of the X's. It's
Okay.
not the sum of means, it's the sum of individuals.
Okay.
And then comma, and the way it works now is 6.7 times the square root of the sample size, which is 15. So a couple warnings. First thing is most people get this wrong when they give it on a test. It's easy to watch, isn't it? I bet none of you were having trouble watching, were you? So when you see the word sum, I don't know what I can do, but somehow bang your head so that you write 2.8 times. Don't write down, it won't be 2.8, but you multiply the mean times the sample size. You multiply the standard deviation times the square root of n. You get a little note sheet, so you can put those formulas in your note sheet. But again, most people get this wrong. So try to remember to do it. Can you promise that you'll at least try? Okay, because it is one of the hardest things for people to do. And I don't know what I can do to help you to remember. And I don't give trick questions. It'll have the word sum. It could have the word total, which means the same thing. But it'll have one of those two words. Can you remember that? Whereas if you look at part B, it had the word average. Do you see that? Part A didn't have either of those words. They're very different questions. Any questions so far? Okay, so now we're going to need this 2.8 times 15 is the same as 1.4 times 30, which is 42. Can you all do that in your head too? Just kidding. So I'm a weird person. I like to do arithmetic for fun. But you don't have to. You can use a calculator, but you need to. So what I'm going to do now is draw my picture. Beautiful little normal curve. I'm actually doing pretty well today on my curve. That wasn't the best little line though. And that number is not 2.8, that number is 42. And that's really important. People just like crash on that piece. Any questions so far? We need to find the IQR. We do not know the values of X for that, but we can kind of eyeball it. Let me use red. We can kind of eyeball it. Something like that. It looks like about 50% of the area is in between, right? So how much of the area is to the left of this value? What's the answer to that?
25%.
Yeah, 25% or 0.25. That's really important that you should know that because that's IQR. So 0.25. And similarly, if you look at all of this to the left of the far right line, that's 0.75. And I guess I should do some shading. So maybe I'll double shade. What am I see. There we go. So I'm going to shade that one in red and the other one in purple. So the purple area is 0.75. The red area is 0.25. Any questions on that? Okay, and we want the probability, we want the numbers such that the area is there. What do you use in your calculator when you're given the area and you want the value of x? You remember?
Inverse.
Yeah, that's going to be the inv norm. So now I'm ready to go to my calculator and make it happen. So I'm going to go second, distribution. Inv norm is number 3. The area, the first one is 0.25. Whoops. The mean was 2.8 times 15, or 42. The standard deviation was 6.7. And then times the square root of 15. Paste it in, hit enter, and I get this. Any questions on that? Now let me show you a trick. I don't have to do all this again. If I go second entry, and I go over, I don't know if you've seen this trick before. I just want that 2.5 to be a 7.5, right? So I go over the 2 and make it a 7. Isn't that cute? Okay, you could go back and do inverse norm again, but this is a lot easier. And then enter. And you get 59.502367. So now I could take 59.5023 267, and I can subtract 24.4976733. And there's my IQR, about 35. So IQR was 35. So let's write out IQR was equal to 35. 35, there we go. Now let's talk about the normality assumption. Was it needed or not?
Yes, it was needed because it was only 15, right?
Yeah, our sample size is less than 30. Less than 31, actually. Could say less than 31 or less than or equal to 30, either way. And then I've done my 4 things. Any questions at all on this example? Any questions? Okay, I think I'm going to do one more. And I'll do a piece of the example. But it's a different style, and I figure I should show you the two styles. So this was a survey question that's quantitative. So there's a big breakdown in this particular subject. There's two types. There's quantitative, and there's yes, no. So let's go ahead, and I'm going to get rid of this, all of it. And let's do this one. This is kind of depressing. So according to a recent Gallup poll, 30% of all Americans are engaged in work. Isn't that sad? Okay. Meaning they're involved in, enthusiastic about, and committed to their work and workplace. For each, determine if it's reasonable to use an amount. So basically do all four. Okay. Is it reasonable to use a normality assumption to approximate binomial distribution? If so, use the normal distribution proceeding as in number 6. So I'm just going to do, I think I'm just going to do part A, just for time reasons because it's 7 o'clock. So if you survey 400 randomly selected American workers, find the probability that at least 120 of them are engaged in work. Any questions on the question? Technically, you can use the binomial distribution, but there's a big theorem called the central limit theorem for proportions that says we can use the normal distribution if you do it right. So let me do this example. So the first thing you need is not greater than 30. That is not what you need when it's a yes-no question. And that's really important for the rest of the entire course. So many people make that mistake. For the yes-no question, we need the number of successes of yes to be greater than 5, and the number of no to be greater than 5. That's the same thing as NP greater than 5 and NQ greater than 5, if you want them in symbols. So if 30%, okay, so if 30% are expected to say yes, and you ask for 100, then 400 times 0.3 is equal to 120, right? And that is very much greater than 5. And then 400 times 0.7 is equal to 280, if I did my math in my head right, which is greater than 5. Any questions on that? So that means the normal distribution applies. So it's very important to know for the yes-no question it's different than for the quantitative. Any questions on that? Then we're going to have some formulas. The first thing is we're going to say no longer x or x bar. Now we're talking proportions. What letter to use for proportion? Not a trick question.
P.
P. Okay. Except P is for the population proportion. For the sample proportion, we're going to use, and the formal word name for this is P hat, because P with a hat on it. We don't do the Greek like mu, because I used to, when I first taught this class, I used Greek. Do you know what the Greek letter for P is? The hint is you all do. You all know it. Pi. And it confuses the hell out of everyone if I use the letter pi. Does that make sense? So we use p hat for the sample proportion, use p for the population proportion. And then I can do the rest. Tilde n. And then the mean is going to be 0.3. It's the mean proportion now. And the standard deviation, you just got to remember this or write on a note card. It's going to be the square root of PQ over N. So 0.3 times 0.7 divided by 400. Any questions on that? Okay. The interesting thing is this one I don't even have to use a calculator if I understand it. So let me show you why. If I draw the normal curve, which I have to, then our mean proportion is 0.3. Oops, I gotta do this. What is 120 divided by 400? Because that's the proportion that we want to find out, at least 120. Point 0.3. So now I draw my picture. That's why I like this particular example, especially to end the day. We want to be at least 0.3, and you shouldn't even have to get your calculator on this one. What is the answer?
0.5.
0.5. Exactly. Exactly, because it's half the curve, right? So the answer is 0.5. I'm going to write p hat is greater than 0.3 is equal to 0.5. Any questions on that? Any questions? Okay, that's about all I have to say. I need to do something. I might pause for about a minute because I realized I forgot to do something. I apologize. I've been really busy today. It's been one of those days. You ever have one of those days? So I need to do something or we're going to run into all kinds of problems in this class. But just a second, and you'll agree with me that you'll want to do this too. You'll want me to do this. Just a minute. I hope no one's tried this yet, because if they have, it's wrong. Well, you know, I can just keep it. I think it's okay. Since I've already taken it. Just a second, sorry. That'll work, because I haven't even said it, which is good. It's a good time to say it. So, secret word. That's what I was looking for. By the way, you should never try to take the quiz before I give you the secret word. I know that it said someone's tried to do it already. So
I think I did by accident. I think I meant to put in last week's secret word, and I accidentally put it in this week.
Ah, okay. Yeah, it can mess you up sometimes. And because I didn't even know the secret word, actually. So let me give it to you. I guess we'll leave it from what it was last time because I forgot to change it. It's going to be standard error. So standard error, by the way. Oh, let me write down. I forgot. Secret word. Standard error is a word for the standard deviation of the sampling distribution. So that's that whole sigma divided by the square root of the sample size is the standard error. Does that make sense? So that's the word we use for that. And standard error, it's 2 words actually, is a secret word. So as always, I will stay online and answer any of your questions. If you don't have any questions, then you can say goodnight. If you do, then I'll be happy to answer whatever you've got.
Are we allowed to use the 3x5 card for the test this week?
Well, let's just put it this way. You can take it at your home.
What?
You're going to be taking it at your home this week.
So we can use our we're not going to be cheating.
Yeah, no, definitely, yeah. Yeah, what you're not supposed to do, and again, it's on your honor, is don't, like, pay someone to take it for you.
Oh my God. Okay, no.
Okay, you're laughing. I get offers a lot for other classes to take their test for them. And it's like, give me a break.
You do that for us? You're so cool. That's awesome.
Oh, would I take your exam for you? No. I say no, by the way. If they want to give me money, and I say no. Come on. So, you know, that would be cheating for sure.
Okay.
You know, don't ask other people. But this is, you know, a test that you're on your own honor for. But yeah, definitely have a 3x5. The other reason to have the 3x5, it'll kind of get used to writing a 3x5 for the regular test.
And then, are you going to be really a stickler when it comes to the rounding from a 9 to an 8 or whatever at the very end of the 4 decimal? Sometimes you kind of like.
Right. For first thing, it's only kind of me. Remember, it's a computer, and I'm not a computer. So computers are sticklers. But for the chapter 6, there were some problems with that. I fixed that. And what I did, but
anyway, is it like if it's like 0.023456?
Right. So round to the nearest 4 decimals, and if you're off by a little tiny, it'll still be okay.
Okay.
But a tiny means that 4th decimal could change by 1 or 2, but not the 1st decimal.
Okay.
You know, or the 2nd, maybe even not even 3rd. But the 4th decimal is a little more flexible than it used to be. Does that make sense? So yeah, I noticed that there were round off error issues, so I fixed that for chapter 6. And I apologize for the few people that it caused some stress on.
Yeah, that happened to me last time. I had to redo the same problem like 5 times because I was off by 1 number. It was.
Yeah, so if there's a problem, post on the Q&A forum, and I fix it.
Oh, okay.
And not only are you helping yourself, but you're helping everyone else too. Because I'm trying to make this good for everybody. You know what I mean? So I did fix that. So if it happens in chapter 7, let me know. I haven't checked to see if there's any issues, but you'll know. Post on the Q&A and then I fix it. I'm usually pretty quick about it.
Was there a quiz for week 4 secret word?
What's that?
Was there a quiz for week 4 secret word? Because I don't see it on my.
Did you go to the module?
Yeah. Well, it's not even on my grades.
Then go to modules.
Okay.
And go to week 4.
Yeah.
And there should be under assignments, you'll see week 4 secret word quiz.
Oh, there it is. Okay. If I put it in now, because I did watch, I just didn't see it. Am I going to get credit or?
I'll tell you what, send me an email. Please,
Okay.
Doug, and be nice.
And
But
are you going to be able to delete
have to do it by Sunday.
for this week?
Huh?
Are you going to be able to delete the one for this week?
But actually, I think I didn't set a due date on this, so hurry up on it before I
Okay.
set a due date.
Thank you.
Just realized I forgot to set a due date, and the due date should have been last Sunday. Should have been yesterday.
Okay.
So hurry up on it before I change,
But I got to remember what it is now.
you have to go and look
I'll
at the
do it
quiz.
though.
I mean, at the video.
All right.
Larry, I have another quiz for the exam.
Another,
Another question.
oh, okay, okay.
How do you take it out of the review mood? Since I go to view your scored assignment, and all it gives me is basically another review. It allows me to show answers.
Really?
hmm
Did you find it going week 5? I think you had that problem with something else too once.
On the modules?
Yeah, did you go to the week 5 module
hmm
under assignments and click on online exam chapter 1 through 5?
Yeah, so it brings up the review mode and then go to scored assignment. And it gives me the question, but also gives me the option to show the answers.
Yeah, because you're in review mode and that means you're not getting credit for it.
Okay, yeah, so how do you take it out of the review mode?
So I'm wondering what's happening with you. Because has anyone else tried? Any of you are at your computer, you could try, see if it's just you or everybody. I'm going to open up my gradebook. It's the site that you don't even know about. Online exam. Fall 17. Whoops. Oh, wait a minute. Let me change something. That's weird. I thought I changed that.
Yeah, I have the option to see the answer too.
Yeah, you won't in a minute. And by the way, when you try it again, it won't show you the same answer. So just a minute. That's because it's in review mode, but it won't be soon. Always after start date. Available after. There we go. Just a minute. Sorry. January. It's due on. Let's see. That'll be Sunday the 14th, right? Yeah. Show scoring these questions as it's submitted. Let me double check. Sorry about that. It takes a minute to do this. I thought I checked this earlier today, though. All right, try to refresh and see if it happens again. Did anything change?
I'm getting to it.
Okay.
No, it's still giving me the option to show the answers.
Okay, because it's showing as review. Just a minute, it shows as review. Yeah. The date is right. Okay, so let me see if there's some review mode thing here. Let me do this. Hide show dates, just a minute. Available after, that's fine. Always after, sorry. Keep open as review. Let me do this for now and I'll change it. Okay, try it again. It looks different.
It's telling me this assignment is closed.
Now it's saying closed. Okay, well, at least it doesn't let you look at it again. Just a minute. So, available after. 10/7/17 at 10 p.m. And then it's available until, oh, sorry. I really screwed up. You're going to laugh if I tell you what happened. You want to hear it? Don't think I'm an idiot. I thought it was January.
Long day.
Now it should work.
Yes, there we go.
Yep.
It worked for me too.
Yeah, sorry about that. I was literally thinking January, not February. Not used to being February. Do you know what the problem is? We have no snow. I'm still waiting for winter.
We're not going to have one.
I'm not going to have one. Don't say that.
All right. Thank you, Larry.
Okay, so thanks for letting me know, by the way, because it caused everyone else frustration. And now there shouldn't be any. Now it should just work. Any other questions?
I have a couple of questions on last week.
Okay.
When it comes to the IQR, calculating the outer of 75% and then subtracting that. So I was doing, based on what you just did today, is you take the 75 percentile and minus it to 25. And that's for any IQR, right?
Okay, so why don't you repeat your question exactly, because the wording is important.
So I was doing the IQR and you asked about the 75%, kind of like we did on the last problem on the normal distribution.
Mm-hmm.
But I was doing greater than 75% instead.
Right. Now, so if you do the IQR, and I'm drawing the picture as we go, looks like that. And what you do is this guy is 0.25.
Right.
And then this guy is 0.75.
Okay.
Picture tells you everything. Does that make sense?
Right. And so you always take the 75% and you minus the 25%.
Exactly. And that'll give you the IQR.
Okay. Yeah, I was doing the higher, trying to find the probability of the 75%.
You were trying to find right, 75% above. Actually, that's the lower quartile. That's
Right.
Q1.
Right. So I was doing that, and then I was subtracting that, the 25.
Right, and it was probably giving you 0 then.
Yes.
Yeah.
It kept giving me 0.
Yeah, and that's because basically it gives you the same. You're subtracting from itself.
Right.
But now you understand. The picture tells you everything.
Yes. Thank you.
Okay, well, thank you.
Have a great night.
You too.
I have a quick question. For the proctored exam, can you walk in with a note card already filled out, or does it have to be blank and then you fill it out?
No. The whole point is that I don't want you to have to memorize formulas.
Okay.
Yeah. So, but it's a 3x5 note card. It's not like huge.
Okay.
So it's enough to put the formulas on. It won't be enough to put examples of every kind of problem on.
Okay.
But yeah, it's up to you. I tell the proctor, whatever, as long as it's 3x5, front and back, whatever you want to put on it is good.
Okay. Sweet. Thank you. Have a good night.
You too. Have a great night, Michelle. And Sean, we lost you. Elizabeth, you said good night. So, all right, for all those who are watching this as an archive video, thank you for watching this, and please post your questions on the Q&A forum. Have a great night.